Hello, good morning, children. So, as you all know, we have started a new chapter called energy, isn't it? And in the last video lesson, we learned about what do we mean by energy, and we have introduced ourselves with a simple machine, isn't it? Let me recall a bit. A simple machine is a very basic device, mechanical device, okay, which will help us to do our work easily and in a very convenient way. As I told you, there are 6 different types of simple machines. They are lever, inclined plane, wedge, screw, wheel and axle and pulley. Alright, so number 1 is lever, number 2 is inclined plane, number 3 is wedge, number 4 is screw, number 5 is wheel and axle, and the 6th one is pulley. Alright, so we will be learning about these 6 simple machines in detail. Okay, so today we will be learning about the first simple machine, that is lever. Okay, so again, to learn about lever, let me again recall the terms that we have learned in our last video lesson. First is fulcrum, denoted by F, and I hope every one of you have copied down the notes that I have provided in the last week class. Okay, so fulcrum denoted by capital letter F. So what is fulcrum? It is a fixed point on a machine, okay, through which the machine turns about. Okay, so the point on a machine through which it can rotate or turn about is called fulcrum. Next one that we learned was load, denoted by capital letter L. The force exerted by a machine to move an object is known as load. Alright, so you can refer your copy right now. You can open your copy to the page where you have copied the notes that was given in the last class. Third term that we learned was effort, denoted by capital letter E. Okay, what is effort? Effort is the external force that you apply on the machine. Since you all know that a machine cannot work by itself, so you have to put some effort on the machine, some force on the machine, so that the machine can do work for you. So the force that you have applied on the machine so that the machine can do work for you is called effort. Alright, then comes your velocity ratio. Now what is velocity ratio? That was the fourth term that we have learned in the last class. So velocity ratio, it is the ratio, or that is the comparison of velocity of effort to the velocity of load. Understand? Then we learned about mechanical advantage. What was mechanical advantage? It is the ratio again to the load or to the effort. So the ratio of load, okay, that is the force, okay, exerted by the machine to the effort, that is the force exerted by a person or some external source on the body, on the machine. It's called effort, isn't it? So the comparison of these two, load and effort, is called mechanical advantage. Then comes your efficiency. Now what is efficiency? Again, efficiency is the ratio of the output to the input. How much work the machine has done for you and how much work you have done to the machine. The ratio of these two gives you the efficiency. Then comes your input. What is input? Input means the activities, the effort, the force that you're applying on the machine. Okay, that energy that you're supplying on the machine is called input, whereas the work done by the machine for you, or the energy, output energy that you get from the machine, is called output. So these were the things that we have learned in the last class, and this topic, efficiency, this was the last topic that I have discussed with you all in the last video lesson, isn't it? So now we will begin today's lecture. Okay, that is concept of an ideal machine. So here we will understand what do we mean by ideal machine. All right, so underline here, an ideal machine is that in which the work done by the machine is equal to the work done on the machine. So if you have a machine where you find that input is equal to output, Understand? So if you have a machine where you see that the input, okay, that you're applying on the machine is equal to the output given by the machine, such kind of machine is called ideal machine. All right, so which means that it can convert the entire input energy to the output energy, and very important thing here, it does not waste the energy. So here ideal machine does not waste the energy. But remember, my dear children, practically in our daily activities there is no machine which is ideal machine. So in practical we have a machine called as real machine. Now why we cannot have a ideal machine? Because some amount of energy is always wasted, that is dissipated in a machine due to the friction between the moving parts. All right, and secondly, there are no machine which is weightless. Understand? So there is no machine which is frictionless and weightless, hence we cannot have an ideal machine. All right, so practically we have only real machine, and in a real machine you should remember that in a real machine output energy is always less than input energy. So the more amount of input that you have given to the machine, okay, that is always greater than the output that you are getting from the machine. Or in simple language you can say that work done by the machine is always less, okay, to the work done on the machine. So there are no machine which are perfectly ideal. Understand? So now I hope you understood. So ideal machine is just a concept. Understand? Practically it does not exist. All right, are you getting my point? Yes. So that is why you have a formula of for efficiency of a machine which is in percentage. So that is what? Output work by input work into 100%. So this is the formula. So you please remember that efficiency. So here this efficiency equals to output work divided by input work into 100%. All right, I hope now you understood what is ideal machine. Now since I told you that there are 6 different types of simple machines which we need to learn, so today we will be just learning the first kind of simple machine, that is lever. All right, so lever. Now don't confuse yourself with the organ that we have inside our body, that is other type of liver, 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 which helps in the digestion of the food that we consume, isn't it? But here this is the liver that we have to study in physics, and it is a kind of a simple machine, and the spelling is lever, lever. Now what is lever? A lever is probably the simplest machine that we are most familiar with. So we have already been using this. You all are using this lever in your day-to-day life, but you have not realized. Okay, you all don't know. तिमीलाई थाहा छैन, but anjanma pani you are using this machine, simple machine called lever. So now as we do the topic, as we discuss the topic, you will come to realize that there are so many levers that you are using in your day-to-day life without realizing that those were the simplest form of machine which falls or comes under lever. All right, so what is a lever? It is a rod which can turn about a fulcrum. Now you know what is fulcrum? Fulcrum is the point on the machine through which the machine can rotate. So machine ma bhako एउटा point, त्यो point बाट चाहिँ lever के गर्न सक्छ, घुम्न सक्छ. That point is called fulcrum. So what is lever? Lever is a rod which can turn about the fulcrum. So an object to be moved is called the load or the resistance, and the force applied to move the object is called the effort or the power. So you know what is load? Load means the obstruction or the resistance that has to be overcome by the machine, whereas effort is the force that you are applying on the machine. All right, so the distance from the fulcrum to the load is known as load arm. Very important thing to be remembered here, load arm. So put a star mark here. And while the distance from the fulcrum to the point of application of effort is known as the power arm or the effort arm. So these two are very important now in case of lever, load arm and effort arm. So let me say it again. What is load arm? Load arm is the distance from the fulcrum to the load, whereas effort arm is the distance from the fulcrum to the point of application of effort. All right, so here you can see there is a girl, okay, and there is a load, a big stone is here, okay, and there is a small stone placed here, and this is the point through which this rod, now this log of okay, stick or the log is acting as a lever here, and this is the point, okay, so this is the point through which this log can rotate, so that point is called fulcrum. This girl is trying to shift this stone, so stone acts as the load and she is applying the effort here, so that is your effort. So this distance from the fulcrum to the effort is called effort arm, whereas the distance from the fulcrum to the load is called the load arm, or you can call it as distance, perpendicular distance from the fulcrum to the load. All right, so this is your simple machines, and I hope you have seen, isn't it, people trying to shift or move the heavy load by using this kind of rod. All right, so here you see fulcrum, load, and the effort arm and lever arm, load arm. So these are the 5 important terms that you must remember when we are learning when you are learning the simplest form of machine, that is lever. All right, now how is the lever balanced? How much force is needed to lift a load depends upon the load arm and the effort arm. Less force is needed, okay, if, now you can turn your page, okay, you will find this in the next page, okay. If effort is far away from the fulcrum or if the load is near to the fulcrum, so a lever is balanced when load into load arm is equal to effort into effort arm. Very important relation, or you can call it as equation. Load into load arm is equals to effort into effort arm, and this is what we call the principle of levers. So what is principle of levers? So according to principle of levers, load into load arm is equal to effort into effort arm. This is what we call principle of levers. Levers co-principle, say what is it? It is load, okay, load into load arm equals to effort, okay, into effort arm. Very important principle. All right, okay, now we directly go here, okay, the mechanical advantage of lever. Mechanical advantage of lever equals to effort arm divided by load arm. Just remember this much. All right, okay, now let's see the types or the classes of levers. Now depending on the position of, I told you the 3 things, fulcrum, effort and load. Depending upon the position of these 3 things, levers are classified in 3 classes. How many classes? 3 classes. Levers of class 1, levers of class 2, lever of class 3. Okay, so let us first discuss and understand levers of class 1. The levers in which the fulcrum is in between the effort and the load are called as the lever of class 1. So class 1, you can see the figure here. Fulcrum is here, effort is here and load is here. So load र effort को बिचमा त के छ? Fulcrum. So this kind of levers where you see that fulcrum is lying between the load and effort, such kind of levers are called levers of class 1 or class 1 lever. Okay, you can say it anything in any way. So examples are a seesaw. We have seen a seesaw. In Nepali we call it chakalik chuklik, isn't it? A pair of scissors, right? A beam balance, dokanma cha ni taraju, okay? Tin shears, that means a device to cut tin. The brakes of a bicycle, the handle of a hand pump, crowbars, okay, etc. These are all the examples of class 1 lever. You can see the picture of these examples on your book, okay, on page number 57. So here you can see, here you have a seesaw. There is one effort, here is load, and the fulcrum is here. So if load or effort ko beech mein is fulcrum, so it belongs to class 1. Similarly, you can see a pair of scissors. So the paper that you are cutting is acting as a load. You are applying effort on the handle, and this is the point through which the scissors can move. That is called the fulcrum. So fulcrum lies between load and effort, so it belongs to class 1. Okay, similarly, a crowbar here is an example of class 1 lever. All right. Now let's move to the levers of class 2. The levers in which the load is in between the fulcrum and the effort are called as the lever of class 1. Alright, so here, here you see this is the point through which the lever can rotate, so that is the fulcrum. Here you can apply the effort, and here is the load. Load L is here, bichma. Fulcrum ra effort. Fulcrum ra effort ko bichma what is there? Load is there. So if you have a lever where load is lying between the fulcrum and the effort, that lever is called as levers of class 2. Examples are wheelbarrow. This is the wheelbarrow. Okay, nutcracker. Yes, here is the picture of the nutcracker. Lemon squeezer. Okay, foot bellows, mango cutter, bottle opener. Here you can see the bottle opener. These are the examples of what? Class 2 levers. Alright, so class 2 levers, what is lying in between? Load is lying in between fulcrum and effort. Alright, now the last class of lever, okay, is, now see, first you saw fulcrum was in between. Second you saw that load was in between. Effort. So now if you have a lever in which effort, okay, is in between fulcrum and the load, that kind of lever is called class 3 levers or levers of class 3. So here you can see fulcrum is here, load L is here, and this is the effort. So here effort is in between fulcrum and load. This kind of lever is called levers of class 3. Okay, so let us now see the examples. Some examples of class 3 levers are forceps, chimney. So you have seen, see, these are the things that you have seen in your day-to-day life. So you have not realized actually, isn't it? Yes, तिमीले चलाइसकेको छ यो सामानहरु, but you have not realized it. All right. So similarly, a pair of tongues, Nepalima we call it as chimta, isn't it? A fishing rod, you have seen this. Yes, your hair clips. There are so many things, scale, pencil, all these are kinds of levers. Okay, so now here 3 examples, the pictures of 3 examples of levers are given here. Class 3 levers are given here. So please see and try to understand it. Okay, now let me again recall about the 3 classes of levers. Okay, so if you have a lever, okay, so I have drawn the 3 rods here. Okay, here I have drawn the fulcrum, here I have drawn the fulcrum, and here I have the other fulcrum. Fulcrum F, fulcrum denoted by F, fulcrum denoted by F. Alright, so here I have the effort E, here I have the effort E, and here I have the effort E. Here I have load, here I have load, and here I have load. So here in the first picture you see fulcrum is in between effort and load. Effort or load ko bichma ke cha fulcrum cha, bichma ta ke cha fulcrum cha. So when fulcrum is lying in between the load and effort, it is called class 1 lever. Okay, class 1 lever. When load is in between fulcrum and effort, it is called class 2 lever. Okay, and when effort is in between fulcrum and load, it is called class 3 levers. Okay, so just remember the 3 letters here: F, L, E, flea. F, LE. fulcrum बीचमा छ भने क्लास 1, load बीचमा छ भने क्लास 2, effort बीचमा छ भने class 3. Okay, and you must remember the examples also. Alright, so I hope now you understood the simplest form of machine, the first simple machine that we have learned today, and that is levers. Alright, so now again you go back to the page 57, and I hope you have underlined all the examples. Okay, please underline with your pen on your book with your pencil. Alright, okay, now here you have on page number 57, the topic says enrichment and levers in human body. In our body, okay, on our body also you can see different parts where the different parts of the body acts as a simple machine. For example, here you have a forearm, isn't it? So here on the palm we are keeping the load, effort is on our wrist narima, and here elbow ma chahi ke acting hunदैछ, fulcrum जस्तो हुँदैछ. So here you see that effort is in between load and fulcrum. So when effort is in between, we call it as which lever? Class 3 lever. So lever of class 3. Similarly, lever of class 2 you can see on the toes when you are standing on the toes. Alright, so these are the examples of levers, okay, classes of levers that you can find on our body. Alright, okay, so now I hope you have understood. So if you have any confusions, any queries, any questions, you can always ask in the class group. Okay, so first finish up this video lessons. If you are not able to understand, re-watch it. You can watch several times. Okay, yes, and anytime you can watch it. Okay, now shortly you will be receiving some notes based on today's lesson. All right, so that's all for today. Have a good day.